so we stuff.
Yeah, okay. Well, I can still, I mean, the Zoom meeting thing is kind of in the middle of my screen. But
Just put
that's
it away, minimize it,
okay.
as long as you
Yeah.
can hear my audio.
Oh, I see Jupiter. All right. Very
You see
good.
it? Yeah?
Yeah, I
Okay,
see it.
good.
Yeah.
Let me check how many viewers do we have?
Well, I doubt we have many now.
Yeah,
It's,
I want to see if it's saying anything.
let's see. Where is it? Where you see how many viewers there are? I can't remember. Oh, current viewers, one.
Okay, and you can see the live chat too?
Yeah, I can see that fine. Sure.
Okay, so we're good then.
Yeah, we're good. I mean, there's nothing there yet, but it's early.
Okay, we'll just watch.
Yeah.
Okay, we're good then. I'm gonna go check the other screen and see how well it's working.
Okay. All right. That's a pretty nice view. Not bad for live view.
It's only like 20 degrees right now.
Uh-huh.
Right now above the horizon.
Yeah. Okay. Well, that's the way
Trying
it is.
It's being a little.
Looks like is it drifting a little bit?
Yeah, I just have to get it to be a little stable, and then we should be good. Okay, I got it stable. You might see it now. It's stable.
Yeah. Well, I can see it. Yeah. It was just starting to drift out of the screen.
Okay, I'm gonna be gone for a second. I'm gonna go check something.
Yeah. Okay. Well, whoever is out there, welcome backstage. We're just getting things ready. As you can see, Jupiter has responded to our invitation.
Okay, I can.
Yeah.
Technically, I can see the live chat. Technically now.
Oh, you can. Well, good.
Oh,
Yeah.
I have to turn behind me, but it's on the TV.
Uh-huh. Okay. Well, we had 3 viewers. We've got 2 concurrent viewers.
I'll just put this part away. There we go.
Yeah.
See, okay, yeah, the lag is only like 5 seconds. That's good.
I'm not hearing myself playing back after 3 seconds. That's good.
You probably should listen to the audio. Just because we can hear each other anyways, yeah.
Yeah.
Okay, yeah. I'll just let this view of Jupiter sit. It might be a little difficult for people to see though. I wonder if that looks better for people. Does that look better?
Is that bit? Well, it got smaller on my screen.
Yeah, is this smaller better or is it worse?
Well, I've got, it's very minimized on my screen.
Okay, I'm gonna go check the other TV. Okay.
Should I don't want to do it full screen, right? That's going to block. Yeah, no, that won't work. Okay, if anybody out there, it's not too early to say hello, say who you are and where you are.
Okay, I'm gonna put it back. Apparently I might look better like this. I don't know. Full view. I'm just a little scared of compression.
Uh-huh.
But I think it's fine.
Okay, well, is it imaging and stacking, or
No.
It's just live view, right?
This is just a live view. Stacking is in here, auto stacker.
Yeah, okay. Gee, we have a graph that shows us how many people are on board, I guess. It's interesting.
Yeah, remember, all of you can see the stats. I can't.
Mm-hmm. Okay. Well, don't worry about that.
And I'll have to. And you probably should tell me the questions because I can't. really
Yeah,
see
I
it that
will.
well.
Right. Okay. Well, I can do that. No problem.
Yeah, I'll just be focused on this part. Yeah. Okay. Let me know if anything comes in the chat.
Well, it's 9:20. You know, I don't think people are expecting us to start until 9:30. I mean, if
Yeah.
anybody wants to get in a comment or a greeting early, you are certainly.
Just have to let know when if you're there while I continue to try to make this work a little better. Wait, actually, move that.
Hi. Yeah. Yeah, we're about to go live streaming in I mean, we are right now actually, but we haven't officially started. What? Huh? Well, are you on YouTube? Curiosity Peak Observatory. Okay, yeah, just say hello. You can chat, you know, and we'll respond. Okay, great. Are the kids there?
Yeah.
Oh, cool. All right, everybody. Jupiter is waiting for you. Okay. Okay, bye.
Okay. When it's very low altitude, the tracking isn't as good on this dog, so I have to do some readjusting.
Okay. All right.
It was on a dust mote, so I moved it somewhere else in the field of view. Okay, let me 200%. I think that's good. Maybe people like. I don't know. I don't know what looks better on the screen, so I'm gonna have to.
It doesn't look bad, but you know. Oh, there we go. It's a little. Yeah, that kind of perked it up a little bit.
What, increasing exposure time?
Is that what you did, or was it?
I just changed. I changed the exposure. I increased exposure time and decreased the gain.
Oh, okay. Well, at first it got brighter and then it dimmed again.
I mean,
yeah,
do you want it brighter? It was like this.
Maybe a little bit.
Okay, I'll set it to
Just
220.
a little bit. Yeah.
Nope, that's way too much. 190. 180. Is that better?
No, that's way too much.
What about no? What about
that's
now?
not bad. That's pretty good like that. Yeah.
Okay, if this is okay, I mean, from my screen, I can see a lot of tiny details shimmering into view every now and then.
Yeah, I do too. Yeah.
Okay.
Okay.
Even on your tiny screen?
Yeah, I can see some detail. Yeah.
Okay. Let me go for a second. I'm gonna look at the TV thing.
Okay. If anybody out there wants to tell us, you know, how the image quality is, that would be appreciated. It's gonna get sharpened up though, because right now we're just having a live view, but Vivek will be using some imaging techniques to create a much sharper image. So this is just the introductory phase right now. Okay, so we have a few people on board. Anybody wants to identify themselves, you know, just type in the chat and say hi and where you are and what you're coming from, and
yeah, just sit on this view of Jupiter for. I'll start recording later. Well, like once we have enough people, I'll start doing the recording and stacking.
Yeah. Okay. Well, we have six people viewing right now.
Yeah. Maybe we should start at like 9:32, I guess.
Okay. Well, it's 9:24. Okay. Burning Man, Chip and Lynn, checking in from Pine Hills and Julian. All right. Welcome. We've got the big guy in the screen there, Jupiter, the largest planet in the solar system. And our great protector, Jupiter, keeps the asteroids in check in the asteroid belt so they don't go flying all over the solar system, crashing into the Earth and causing a mass extinction like what happened with the dinosaurs. So we should give some appreciation to Jupiter. We probably wouldn't be here without Jupiter. Okay, just a greeting to everyone. I'm Doug. I'm in Julian. Beautiful night tonight. It was 104 today in the shade, but it's gotten down into the high 70s. Pretty nice. And we're going to be we're connecting with Vivek. He's over in San Marcos, and that might seem strange. Why would he be in San Marcos? Well, he's got his telescope there and his camera, and for reasons we'll explain a little later, sometimes San Marcos can be a better place to do this than Julian. Okay.
Let me see if I can show there's one moon.
Okay, that's one of Jupiter's moons.
I don't know about the other ones though. There's another one. Yeah, you can see they're pretty far away from Jupiter itself. And they're also... Yeah, so I guess we won't focus too much on the moons themselves in terms of looking at it, but they're there.
Yeah, those moons are...
Oh yeah, at 11 o'clock, at like 10:40, Europa will emerge from Jupiter's shadow, and we'll be able to see that, so...
At what time?
10:40.
Okay. Okay, that'll be the late show.
Yeah, that'll be the late show for anyone who wants to see that. Europa will come out of Jupiter's shadow, and we'll see that moon near Jupiter.
Yeah, that's one thing interesting about Jupiter is Jupiter's moons transit in front of Jupiter, and they go behind Jupiter. So those are things we can actually watch as they happen. Okay, then we got Jupiter.
Jupiter's rotation period is 10 hours, which is pretty quick. So if you notice very carefully, you'll see. You might be able to notice that the Great Red Spot's going to transit at like 12 a.m. So very close to the end of our star party at like 10 like at 11. Then it might start emerging from the left part of Jupiter's disk. That's also part of the late show.
Yeah, but one rotation every 10 hours. It is spinning way faster than Earth.
That's actually why, if you look at Jupiter itself, you can see it looks a little squashed. It isn't a perfect circle. It's a bit elliptical. And that's because its very fast rotation basically causes equatorial bulge, and that makes it more like an oblate spheroid, so more elliptical when we look at it.
Yeah, if it went any faster, I guess it would be even more oblate. Okay, we got, besides Chip and Lynn, Kathy Hansel is here from San Diego. And she just looked at Jupiter and its moons with her small telescope last week. Cool. Keep at it, Kathy. That's great. Okay. Well, anyway, I'm going to start talking a little bit about what's involved here with observing planets. Compared to other things in the sky, most planets they're usually quite small. Only measure their diameter. We measure in arc seconds their apparent diameter. If you think of the moon is, I think, 30 arc minutes across as we see it. So an arc minute is 60 times an arc second. So these are small objects. Kind of, observing them is kind of like looking at a neighbor's Christmas tree ornament from across the street and trying to make out the details. So how do you do that, especially given that we live on a planet with a nice breathable atmosphere, but that atmosphere also is an impediment to being able to see very small details on things like planets. So one of the challenges, how do you overcome that? And that's going to be a good part of our subject tonight, is how do we get these clear, detailed images of Jupiter and Saturn and so on when we live in this fishbowl of swirling air around us. So we're not out in space with a telescope out there. We have to make do from the Earth. So Vivek's going to give us a demonstration, explain how you do it.
Yeah. And then we'll probably talk a lot about what's going on with these planets and why what they're like, what like the actual astronomy of it. Yeah, the planetary science. Yeah.
Okay.
We're
Yeah,
also
Margaret. Yeah, go ahead.
we're also gonna go to the moon and Saturn too. So we basically have 3 objects for tonight. We're gonna circle back between them.
Yeah, the moon is close to a full moon, which means it's extremely bright. But there's still there's still a little area that's not completely illuminated. So we'll have that's called the terminator, where the light and the dark area meet, and that's where you see the detail. Anyway, welcome Margaret Luce, another San Diegan here. Cool. First time, I guess. Anybody else want to sign in? Let us know you're here. Okay. We got 20 viewers now.
Yeah.
So Vivek, do you want to say a little bit about the technique involved?
Okay, so I mean, how about you can start about seeing, I guess. You can talk about that.
Okay, yeah, well, seeing is something that it's an expression that astronomers used to describe something very specific, and that what that is how stable the atmosphere is or how turbulent.
Yeah. If you look at how right now, if you'll see how it's like there's like a shimmering effect to it, and it's very wobbly. That is the effect of the atmosphere itself distorting the image that we're seeing.
Yeah, that's why Jupiter seems to be bouncing around. It's not really bouncing around. It's just the atmosphere is moving. It's like if you were, looking down in a stream of water and there was a fish there and the water is swirling around. The fish would seem to be moving even if it was standing still. And that's the refraction caused by the medium that you're looking through, which in the case right now is the air.
Yeah, right now Jupiter is very low in the sky right now. It's probably only say around 23 degrees. So we're not the best views come when you're higher up, and so
yeah.
As we go across the night, it's going to become more and more stable, but we already can kind of see some stuff going on Jupiter.
Yeah.
But this problem with seeing is why one of the reasons why space telescopes exist, because we don't want a resolution to be limited by this phenomenon that's very, very, really severely limits our ability to resolve. It's like the final factor of resolving planets, or even if you're trying to do imaging of deep sky or observing them, this is one of the problems you have.
Yeah, one of the things, even though Julian, the sky is much darker than San Marcos, but because where we are, is Curiosity Peak, we're kind of right above the desert, so we get some turbulence fairly frequently because of the hot air rising and colliding with the cooler air. Out there where Vivek is, it's not as dark, but it's more stable. So that's an advantage for planetary imaging.
Yeah, for planets, light pollution doesn't affect the planets because they're very bright, and you can clearly see them in the sky pretty much wherever you are, as long as it's not extremely cloudy. But yeah, so having very clean, flat topography like an ocean or a flat plain is one of the ways you get good seeing. Or you can go very, very high altitude. Say if you go up to Mauna Kea or Chile, then you don't have as much atmosphere, so you have better seeing conditions. But in Julian, where you have a lot of hills and you have that kind of terrain, you don't really get the best seeing for doing that. So that's why if you try to do say image planets, it's better to have a flatter terrain, even if it's light polluted, than if you're on a hilltop surrounded by more hills.
Okay, we have a question from Fred Delgado in Tijuana. He wants to know if you're using a 12-inch scope, or what kind of scope.
Oh yeah, so this is the same 12-inch Dobsonian as usual with an ASI 224 MC. That's a color camera. It's a very tiny color camera. You only have 1304 by 976 pixels. But that doesn't matter because the planets are very small. And one of the things about planets is you want to get if you want to image them the best, you want as many frames as possible. So having a very tiny camera is actually an advantage because it means you don't have to download as big of a file size, and therefore the frame rate, or how many frames you're capturing per second, is higher. And additionally, like, in order to get the planet to be as highest resolution as possible, we have something called a Barlow. That basically extends the focal length of the telescope by a factor of 3 to get a high resolution image.
Yeah, it increases the magnification considerably, because these are fairly small objects in the telescope. So, okay. All right. So, yeah, Margaret commented on the moon, which is pretty bright tonight, but it's not going to bother us because we're looking at planets, and we don't need really dark sky.
One of the things, like, for observing the moons, if you want to get the highest amount of detail, actually one of the worst times to see the moon, if you're trying to look for these tiny little details on the craters, one of the worst times is full moon, because the terminator, or the line between the dark and the light between along the moon, that's not visible during a full moon. But if you're observing at a different phase, like at half moon or quarter moon, then you get to that line where it's between day and night on the moon. That's where you get the most detail on the terrain of the moon. So.
Mm-hmm. Okay, Lynn wants to know what the two stripes are on Jupiter.
Yes,
okay.
those
Very
are
good question.
So between those two stripes is the equator of Jupiter, and we call those two stripes the equatorial belts of Jupiter. So, and the reason for their coloration, why they're red, is due to the chemistry in those clouds. So specific, like, once we look at the actual processed image from this, then we'll actually see a lot more of the detail. But yeah, I'm gonna explain how we're gonna get that detail, how to get that detail out of this right now distorted view of Jupiter.
Yeah. Okay. Fred wanted to know if he sees the great red spot, but I don't think so.
If you stay up until, like, if you stay with the stream all the way up to like 1040 to 11, it'll start coming out of the left limb of Jupiter. So that's something to watch out for if you're able to stay that long.
And then we're gonna have a moon, one of the moons, Europa, appear also, right?
At 1040, it's gonna come out of Jupiter's shadow, so it'll blink out, and we'll be able to see it.
Yeah. So.
Okay.
Take a few sips of coffee and stay with us.
Yeah. Okay. Do you think it's a good time to start getting down to the process?
Yeah. Okay. Why don't you talk about the process?
Okay. I'm gonna start.
And you're gonna see how it works too, not just hear about it. Okay.
So I'm gonna take basically a video, because I want it to be a high frame rate video of Jupiter. So actually, let me set this correctly. Get it centered. It's pretty much good right now.
Okay, I'm just taking a look to see what it looks like on the full screen. Yeah.
Okay, I'm gonna take a 2-minute video. The reason for 2 minutes is because Jupiter is still rotating very fast. So in order to make sure that doesn't ruin the final image, I want to only get a very quick video of that Jupiter. And the video allows us to take a lot of frames, which all show, and some of those frames are less distorted by the atmosphere, so we can use those to see a better picture of Jupiter. But I'm going to start that now.
All right, so this is utilizing some crazy software that has some special tricks that it does.
Well, we'll use that soon. First, we're just going to get the video itself.
Okay.
If you look at I don't know if people can see that, but right now it's at 80 frames per second. The view of Jupiter we have right now.
Uh-huh.
It's a bit... Okay, let me... There we are. 1 more minute to go. Well, that's 5,300 frames.
Wow. Okay.
Yeah, we're gonna get a lot of frames on this.
Okay, I guess Kathy and Margaret saw Europa shadow on the surface of Jupiter a week or two ago.
Yeah.
And that was with a small telescope,
Yeah.
which is entirely doable. You don't have to go out and spend $10,000 to have some fun looking up.
If you want to just see the moons of Jupiter themselves, you don't even need a telescope. You can just use a pair of binoculars, look at Jupiter, and then you'll see Jupiter as a very bright little disk, and then you'll see the dots around it as the moons. So if you want to do planetary observation, you don't even need a telescope. You can see the moons just with the pair of binoculars. Okay, looks like it's done.
Okay.
So here's the crazy software I was talking about earlier. Just gonna first get that video. Basically, we're gonna analyze the image to get the best frame.
So how many frames were taken?
Probably like a 10,000.
Okay, 10,000. It's like shooting 10,000 still shots, except it's a video.
Yeah.
So out of those 10,000, though, they're not all good. Some are better than others, right?
Yeah. Okay. Now, it's gonna do that stuff in the background, but we can just enjoy that live view of Jupiter being played around with the atmosphere for now. Yeah, might take another one. Just for good measure. Okay, it's analyzing the video to find the best reference frame to start using to... Basically what it's going to do is all of the frames that were in the video, it's going to pick the best 30%, and then it's going to basically average those into a much better image of Jupiter that we can then process and see all of the tiny little details so we can really get a good view of Jupiter. So that's called stacking. It's when you average a lot of frames, and we use that for looking at disk objects too, and that's what we've done on earlier star parties. But for this, we're going to be averaging like 3,000 frames, so it's gonna take some time, but it'll do it.
And then you will feel like you're looking through a 100-inch telescope.
The stack. I mean, when you average a lot of frames, it does get... The final stack is actually much blurrier than you would expect. So yeah, that's what you use some processing tools to see. 100-inch telescope. Well, this is only 12-inch.
Okay.
If you want to see the images from a 100-inch telescope, like some of the best planetary images ever taken are from a 1-meter telescope in Chile, and they have the best seeing because they're up the Andes Mountains, and they can see. They don't have to look through that much atmosphere, and they have a huge telescope, and they use these techniques, and that allows them to get the best images of planets possible with that telescope.
Now, which is only 3 times bigger than the one you have.
Yeah. 3 times bigger, 3 times the resolution. That's how the telescopes work. The more aperture, the more resolution. That's why aperture allows you to get more light, but also it allows for more resolution. But that resolution is limited by seeing, so that's the trick. Okay, it's done analyzing it. Now we're gonna...
Okay.
It's gonna align the frames so that we can get a nice image of Jupiter. Align the frames for stacking. Okay. go.
So these are techniques that could not exist until digital photography came on the scene.
Yeah. This is only like 15, 20 years ago. Before, you had to just be happy with the single frame you got, and these single frames would look like these, like this live viewer seeing, it would look like that. So, I mean, in a moment you'll get to see what digital processing allows you to achieve, but
let's see if anybody out there knows who the first human being was to notice the 4 moons of Jupiter.
hint, they're named after him.
Amateur astronomers need not answer. Okay. Hi, Kevin. How you doing? Okay, nobody's come up with it yet. We were going to give away a free telescope to maybe, or loan a free telescope anyway.
That'd be nice.
Yeah.
Yeah, loaning free telescope. Yeah, we can do that.
Yeah. Hello, Rhonda. Yeah, Rhonda probably needs a telescope for her kids.
Okay, that's better.
No, nobody answering yet. Who is the first human being that we know of to observe the four moons of Jupiter? If I told you what they're called, that would give it away.
The key part is we know of.
Okay, Galileo. Okay, you
Yeah.
got it, Margaret. Cool. Yeah, changed the world when he saw them. Like, gee, Western civilizations said that the Earth was the center of the universe, and here are these moons going around something other than the Earth. Got him in a lot of trouble, but hey, sometimes trouble is what you want to get into if you want to see things go forward.
Perhaps we should we go on to look at some stuff on the moon? Well, I guess we can cycle between objects.
Yeah. Okay.
While we're waiting for it to stack.
Okay. Yeah, we're waiting for this process to happen, but we can.
I mean, if people want to see the moons again, I can show that very quickly. I just have to turn up the.
Sure, the 4 moons. If they're
there, they are again.
Except one of them is hidden.
One of them is in shadow.
Yeah.
There's 2. I bet the one on the bottom left is Ganymede. Oh, and that must be. I guess that must be Callisto over there, or I don't know. I think it's Io, maybe. It's not that easy to tell when you're observing them like this.
Okay, well that's Jupiter we're looking at now, right?
Yeah, of course.
Okay, where I didn't see the moons.
Want me to show them again?
Okay.
I mean, there's one right there. If you can see it. That one. You can see how badly the atmosphere is distorting it.
Okay, there it is. Oh yeah, it's jumping around. It's like looks like a tadpole trying to.
Maybe I think we should look at which one that is.
Okay.
Need a planetarium for that. Not when it looks like that, jumping around like crazy.
Yeah. Yeah, that's a real good example though of what the atmosphere does.
I think we got something from live chat.
Okay, yeah, we're getting some commentary about Galileo, who is definitely one of my heroes. He spent the last 7 years of his life under house arrest for not recanting his discoveries.
Oops. Nope. Just said it. Okay, let's go look at the other moons. That one is a moon. There we are.
Oh yeah.
Those are moons. Let me look at which ones there are. Yeah, this is what the sky looks like right now. And that's Jupiter. Aha, okay. Got it. Okay, that makes sense. This is Ganymede. This one over here. This one's Callisto. Well, let's go cycle back. Back to Jupiter. That one in the center is Io. And Europa's in shadow, so we don't get to see that yet.
Okay. Could you say a little bit about Io? Io's a little different.
Io's very interesting, yeah. So let me get a better view of that. An actually decent view. Okay, let's turn this down. Yeah, it's very hard to see that. It's bouncing like crazy, but Io is one of the Galilean moons, one of the 4 largest moons of Jupiter. This one's particularly interesting because has a lot of volcanic activity. So basically the entire planet's surface is covered in volcanoes, and what they do, and a lot of them emit out, and it creates these bands around Jupiter. And if you actually look at a picture of if you study Jupiter, what you can notice is that there's actually a sodium cloud around Jupiter just because of emissions from the volcanoes of Io. So Io is a very interesting object in that way. And the reason why it's so volcanic is because the effect of the gravity of Jupiter itself, basically, it causes the core to stretch and compress, and that's called tidal heating. So it heats up the core, causing this volcanic activity to occur. So that's Io. Give me a second. Still not done. Are we getting anything from live chat?
Yeah, Margaret had something to say. Well, people were talking about the sacrifices that Galileo made for the sake of science, and how he persevered in that and set an example for others. Margaret's mentioning a movie about the Hypatia of Alexandria, who did some experiments to ponder the question about whether the Earth could be moving, and thus not the center of the universe, because the Ptolemaic view was that the Earth was standing still and that everything else was moving around it, which, you could kind of infer that by just watching the sky going through its daily motion or apparent motion, but it's actually not, the sky isn't what's moving, or the stars and so on, it's the Earth turning. But, people were told not to question that the Earth was the center. She got in trouble too, apparently. Wow. From the Library of Alexandria. Okay.
Shall I move the live view to the moon?
Yeah. Okay. We're going to go to the moon.
Because we're waiting for the stacking.
Sure. Yeah. There is a little bit of a terminator on the moon because it's not quite full moon, I don't think.
Yeah.
Right?
It's at the very left limb of the moon. Ah, there it is. There's the moon. It's very bright. Obvious. There we are. That's much better. Okay.
Okay. Well, the screen just turned white.
Yeah. Had to turn down the exposure.
Okay. Wow.
Let's get the terminator of the moon. The very left limb. There we are. So this is quite interesting.
And we're not talking about that Arnold Schwarzenegger movie. We're talking about the moon's terminator.
Oh, dude, that's a nice crater right there.
Yeah. Oh, yeah.
It's a very nice crater.
You got it focused really well.
Let me play around with the focus. It might be better. Yeah. I put the Dob has a electronic focuser, so to aid in making it much easier to focus. Because getting focused on these things is very hard when the atmosphere is toying around with the image.
There you go. Okay. Okay, we were seeing a mountain inside the crater.
Yeah, that's if you notice, like, if you've ever seen, like, an animation of a water drop, what you can see is, like, when you drop something in water, what happens is it's Newton's third law. There's a reaction back. The water pulls back, and you can see, like, there's like a mountain of water at the very center. It's called ejecta. So whenever you look at a crater, usually on the moon, usually you can see that mountain at the very center because of Newton's third law, the getting hit by a meteor and then recoiling back. Yeah.
And since there's no atmosphere on the moon, it's all like it happened yesterday.
Yeah.
No erosion, except
Yeah.
for further impacts.
That's it. Almost done with the stacking. I should probably take a shorter video because it's taking so long. Okay. Let me get this moon centered so we can start taking some video of it.
Okay.
That's better. Let me play. I think the focus is a little off. Yeah, the moon's very low, so the atmosphere is really doing a number on it. Okay, that's better. Okay, that's good. That's crisp. Let's get a quick 30-second video on that. Don't want it to take too long to stack.
Yeah, I would say if you don't watch it if you watch it on a smaller, less than full screen, it'll be sharper.
Oh yeah, for the people
there you
watching.
go. Yeah.
Let me make it.
Okay.
That's a little too much. How about that?
Uh-huh. Yeah, it's kind of like we're hovering over the moon.
Yeah. Okay, let me see how far this has gone. Still going. Geez, that takes a long time. Yeah, 2 minutes is too long. Okay, 30 seconds. Okay, we're done with that. I'll stack that afterwards. But I guess let's move on to another part of the moon. There's a lot to see up there. We're just right now flying over the surface of the moon. Oh, that's very bright. What is that? Yeah, I think that's
shadows.
I think that's Aristarchus. Yeah, I think that's Aristarchus.
You know, we can see the sun reflecting off the wall of the crater.
Yeah, it's a very shiny crater. So that's a nice crater. Let's get a video on that too. I can get the...
By the way, there's a name for what we're doing. It's called electronically assisted astronomy.
Well, right now it's kind of just like planetary imaging. Just, I'm going between targets. Like the term electronically assisted astronomy, I think that's better applied to like deep sky, like using similar techniques. But for this,
okay.
we're trying to beat seeing over here.
Yeah.
Okay. I mean, we could just zoom in on this crater specifically. Yeah, that's good.
So that's either sunrise or sunset on that crater.
It's sunrise. Because it's not, full moon is like tonight actually. It's very soon. It's sunrise on that crater, Aristarchus. It's good. How far is this? Still going.
Okay, Fred mentioned Tycho in the south, and the rays that emanate from it all across the moon.
When you have like a very, very, very high energy impact, you can get like material being thrown off far away, and it creates these like rays away from the crater. Okay, we have a video on that. See what else we can see on up here. We can go to the lunar. Oh, that's something. That's something right there. Let's see. That is right now experiencing sunrise at the very rim of that crater. Sunrise. And you can also see the ejecta on that crater too, that mountain at the center of the crater. What's this? Oh. Okay.
Okay, Margaret wanted to know if we could reduce the magnification to get a larger view of the moon.
No, I have to change it. I have to change out the camera. I have to take off the Barlow. Yes, unfortunately, we can only study like specific parts of the moon, because we're right now we're set up to do planets and like small regions of the moon.
Yeah, so we need a lot of magnification.
Yeah, so I mean, right now the moon is it's full moon, so there's not a whole lot you can really see on the moon right now, wide field. So right now it's kind of best to just study this part of the moon because that's where you get the contrast in the craters. Okay, let's go to the lunar.
Yeah, the shadows are what give us the three-dimensionality. When the moon is completely full, there are no shadows. So
that's bright. Yeah.
But one of the interesting things of observing the moon is, as the moon, changes from a thin crescent, every night you see different things because of where the terminator is. So there's a lot of people sketch what they see too. A lot of astronomers.
Because if I go to the middle of the moon, you've lost all of the contrast. If you look over here right now, yeah, there's no contrast in this part of the moon here. But if I go back to the that left limb where the terminator of the moon right now is, the line between day and night on the moon, then you got to see that contrast again.
That's Tycho you just went by?
Yeah, we did go by Tycho there. There's some interesting regions all around here.
But full moon is actually a good time to look at Tycho because that's when you see the rays emanating all over from the ejecta from the impact.
Yeah, we might. I don't know if we could. Maybe we can see that. I don't know. I don't know if it's too much. We're right now under too much.
I saw some of it when you passed by Tycho.
Okay, I'm here now.
Okay, there's some of the rays right there. Yeah.
Yeah.
Okay. Yeah.
See how the stacking is going. Oh, so close. Okay. Yeah. Not doing 2 minutes again.
So what about our Jupiter image? You think that's...
It's still going.
Oh, is it? Okay.
2 minutes was too long. Actually, I think it's finishing up here now. It's done.
Oh, it is?
Let's
Jupiter?
get this. Yeah.
Okay.
So let's take a quick intermission away from the moon and see how our Jupiter was going. We're going to open up the stack and see what we got. All right. Yeah, I'm aware. Okay, let's zoom in on that. Now, your first thought might be that doesn't look very impressive. It looks kind of blurry. And that's because this is just a stack. You just average the frames together. But you haven't actually done anything to get that detail out. So that's what I'm going to do here in this program. And we're going to get this detail out. It's almost done. There we are. Yeah, this is the image of Jupiter where you get really see the resolution.
Okay.
Now you actually see stuff here.
Oh yeah. Yeah, you can see that like one cloud band is actually two cloud bands.
You actually see the detail here. I think this is a little too bright, so I'm gonna turn down the. I think I'm gonna turn down the stretch on this. Let's do that again.
Oh, by the way, can I make a little announcement while you're doing that?
Yeah.
We are going to have it, in case we lose anyone before the end, we're going to have another star party on August 15th, Saturday, and that will be a grand tour of the sky. It'll be when there's no moon, and the other thing is it will be during the Perseid meteor shower, so we plan to have an all-sky camera that we can use for a brief interlude and look up and see if we can see some meteors that we can share with you. And we'll be doing that from Julian because the best place to see a meteor shower is where it's dark. So that'll be at 9 p.m. on August 15th. If you want to get notifications about these activities, whether it's virtual or we get back to doing in-person physical star parties, just send us an email to Julian Dark Sky Network at gmail.com, and we will put you on our list to get notified. And you can also go to our website, which is the juliandarkskynetwork.net, and also Curiosity Peak. You can also find out about things going on and see a lot of interesting images that some of our fellow amateur astronomers and ourselves have taken. That's at curiositypeak.us. And actually Fred, who is online with us from Tijuana, is one of the astronomers, and Roy, I suspect, may be listening in. So that's a way you can stay connected with us.
Yeah. So this is the final product of Jupiter. It looks a lot better than before. Look like that. Now it looks like this. So that's what we've done here is we're using algorithms that are able to basically undo the effects the atmosphere did, and we can see the detail. And what you can see here is you can see all that sort of cloud detail on Jupiter. You have those two, the north equatorial belt, the south equatorial belt. If you can notice there's these little blue things going off from the north equatorial belt. Those are called Festoons, and those are one of the more interesting features of Jupiter.
Wait. What do you think? Yeah, we got another wow from Hildaura. Okay. Wow! Yeah, we got several. Okay, good job. Nice.
Yeah, this is stacking on the fly. We're still on Jupiter. I'm gonna stack some of the moon, but I think in the meantime we could possibly just go and visit Saturn.
Yeah, let's do that. I want to see some rings.
Let's go there. Right now we're cut to white, but we get the telescope to go to Saturn. Then we can also take a video of that and do the same process to see detail. And we'll go revisit Jupiter just to see what happened to its rotation. There we are. Perfect. Right there in the middle. Well, not in the middle. Almost.
Now, there's another spot on Jupiter that's becoming well known besides the Great Red Spot. Is that what this is right here? or I'm not sure where it is. I see a few spots.
Are you looking at
And
Jupiter
these
right
are
now?
storms. Yeah.
Yeah, I'm on Saturn right now. Yeah. We can see it in the middle here, but let's get a better view of that. 480. Let's get that centered.
Sesco Maiello, I think from up in Orange County, if I'm not mistaken, brought a telescope to Julian Natural Wonder Fest last year. Hello, Francisco.
Okay.
And if you are going to be out tonight, you can find Jupiter. It's very bright. It's the brightest thing in the sky, aside from the moon. And then right to its left, you will see what looks like a bright star, and that's Saturn, kind of accompanying it along through the night across the sky.
This is Saturn over here. I'm trying to still fiddle with the focus a bit.
Okay. Well, we're still seeing Jupiter. Oh wait, are we on a split screen? Oh, there we go. Okay.
Yeah, I went to Saturn a little time ago. I just try to get the focus. Yeah, but that's Saturn. But let's look at something else about Saturn. Okay, let's turn up the exposure gain a bit. We'll see something interesting around Saturn. There we are. Yeah, those are the moons of Saturn you see around here. I think the one on the top right is actually Titan. I'm not sure if people can... Yeah, I think people can see that. Yeah. So,
yeah.
All those are the moons of Saturn, right there. Let's get... Yeah, Saturn has a quite extensive planetary system.
Four of its moons?
I think there's a fifth one, a fifth very faint one above Saturn's, right above Saturn. Let me turn off the exposure, it might help. Can people see the fifth moon of Saturn? Yeah. Doug, can you see that? There's a fifth moon.
I can see four. Maybe someone with better eyes than
just
mine.
a little above Saturn. You might want to go full screen, yeah.
Yeah, that's what I'm doing, yeah. Okay, right there above Saturn, I see one.
Yeah.
There's a bright one, and there's... Okay.
Yeah.
Oh, you mean, right here, right close to Saturn.
Yeah.
You mean.
Let me let me look up what those are. We can consult Stellarium once again. Because I don't know what those moons are. I just know that one on top right is probably Titan, because that's the brightest. And Titan is the largest and brightest moon of Saturn. Okay. Here we are. Right now it's exactly 30 degrees above the horizon, so... Low. Yep, that's Titan. Okay, so the one just above Saturn was actually Enceladus. That one's Dion, Rhea, and Tethys. Okay.
And Enceladus is the one that spews out water vapor, I think?
Enceladus does have geysers, yes. Yeah, and that's the one right here. It's pretty faint, but you can see it. That's Enceladus. That's Titan. That's Dion over here. We've got Rhea over here, and we've got Tethys at the bottom. There's actually... Yeah, Mimas is right here, but I think it's a little too faint. It's caught up in Saturn's glow. Yeah, aligned with long axis.
Astronomers have gotten very interested in these moons fairly recently because there was quite a change in how they were thought to be all pretty much dead entities with no dynamic processes. But so now what do we know now? It's different. Okay, I get to be busy with the the
Stellarium.
equipment. Yeah, but what's been found out is that some of these moons probably have liquid water that's below a
I don't
frozen
know. I
surface.
tried a little bit.
That there's tidal forces and all kinds of things are at work that cause compression in the interior of some of the moons, and so they have high temperatures and zones between the very high temperature interior and the surface where generally things are going to be frozen. There to be somewhat temperate
Oh,
zones.
that's the wrong direction. I'm gonna try to align it with the moon so people can see that better. Okay, it's to the right now.
Okay, Fred's mentioned that Titan has hydrocarbons.
Yes, has a very interesting composition.
Yeah.
Okay, that's better. There we go. I think that's... Now people can see how it relates to Stellarium a little better.
Someone is speculating that Europa might not smell so good. Is that hydrogen sulfide present?
And Enceladus?
Europa.
No, not in Europa? Oh yeah, that's I wouldn't know. Europa is it's basically covered in ice, and there's evidence that there's a ocean below that ice crust, and we don't know much about the ice crust, but we know it's the reason that we speculate there to be an ocean below that ice crust is because the same tidal heating that makes Io volcanic also can help melt the ice and create a ocean of water. But I'm not sure. I'm not sure about hydrogen sulfide content on Europa.
Okay, we'll have to
I haven't heard
hold
of
off. Okay. Yeah, well, the presence of hydrocarbons and liquid water, we know what could evolve out of that. That's why I think there's plans for exploring.
People are thinking about Titan. Yeah, Titan is, you've got methane lakes and water. The rock on Titan is actually water ice. Like, it's actually just like if you stood on the surface, a lot of that is just really frozen ice because it's a very frigid world. And the lakes are made of methane, liquid methane. And you've got a lot of different hydrocarbons in the atmosphere of Titan, and it gives it a really orange glow. I don't think you can really see that on here, but I guess you can kind of see it's a little orange, but it's not that evident. Yeah. But anyways, I guess we can go back a little to getting a nice image of Saturn. Oh, another one's done. Another one. Oh no, it's not done. I have to.
Are you doing a stacked image of Saturn?
Of the moon.
Oh, okay.
Quickly getting that done. Okay, let's get a good view of Saturn. Okay. So you just focus it before I start recording it. I don't know why it's frozen. Froze a little. That's funny. Oh, I think. Oh yeah, the stacking is making it a little less interesting on the live view side. So we don't need Stellarium for now.
So anybody know the latest count on how many moons Saturn has?
I think it's like 69.
59?
69.
69.
I don't have it keeps going up. Okay, yeah. For now, we won't enjoy a very nice view of Saturn.
So you're taking some video right now of Saturn.
I'm not taking a video.
Oh,
It's right now. It's a little jittery right now.
okay. So Margaret wants to know, is it true that the Cassini division, which is the main division between Saturn's rings, is about 3,000 miles wide?
Can you repeat the question? Is it 3,000? Yeah, it's not that big. It's very small.
Well, 3,000 miles wide, that doesn't sound too small.
I mean, in the context of space, it is small.
Yeah, in the context of Saturn's rings, I guess Saturn's rings extend out pretty far.
Yeah, Saturn's rings have moons inside of them. Consider that.
Mm-hmm. Moons or moonlets, or what are they?
Depends on what you term them.
Yeah.
Depends on how big they are, really, and their influence. Our terminology for the solar system is not that very well defined, as you can see by the entire debate over Pluto. One thing, to be fair, the vote on Pluto wasn't that very fair because a lot of cosmologists got a lot of say in cosmologists who don't even study planets. They got the say in the IAU to vote it. So that's why a lot of planetary scientists are angry about that. And in the literature, they don't even call it. They don't even call they just call them planets or planetoids, because that's how their terminology works. So they're not going to bother changing it just because the IAU changed what they call them. But officially, Pluto is not a planet. But
right, generally referred to as a dwarf planet, or
yeah. But the terminology is not that well defined when it comes to planets. That's why it makes people confused and angry.
Well, it'd be a lot easier if we just refer to everything as satellites of the sun.
Then a lot of specks of dust would fall into the classification.
Yeah, microsatellites.
What defines a microsatellite? Now you have to start talking about size ranges.
Yeah, right. Well, it could be mini, micro, nano satellite. Yes, it's hard to.
Pluto to me is a nice planet.
Things.
Yes, if you want to define it to yourself, no one can stop you. And if you want to make it official, get angry at the IAU for not being that good about it. Okay, I'm gonna take a video. If you notice, I think Doug, can you see how there's like a little blue at the top and it's red at the bottom on Saturn?
Let me get full screen. Okay.
Yeah, if you notice, if you look at Saturn, it's a little blue at the top and red at the bottom.
Yeah.
That's because of the atmosphere refraction.
Oh, okay. That's in the image acquisition, not the planet.
Yeah, but I have a corrector for that, so I need to tune that. So I'm gonna play around with that a little bit so we get a better view of Saturn. It's almost gone.
Okay, Fred says, Pluto to me is the ninth planet. You can call it what you will.
Yeah.
Neil deGrasse Tyson is laughing because he voted to declassify it as a planet.
Yeah. I mean, do we have to listen to the non-planetary scientists?
I don't think so.
I mean, it's kind of famous that the principal investigator of New Horizons, Alan, I forgot his last name, but
yeah,
he still considers it.
Hale, was it? No, not Alan Hale. That's an actor.
I don't remember.
Right.
Shame on me. Okay, I think it's a little better now. It looks much better, Saturn. And you can see the Cassini division better now with the corrector tuned. The corrector only corrects for that color fringe from the atmosphere.
Okay.
It doesn't correct for seeing. In order to do that,
Okay.
you need something called adaptive optics, where you shine a sodium laser to make basically a star that lets you know, that can analyze the movements of the atmosphere, and then you have like an optic that corrects for it in live real time, so the image is high quality. That's what a lot of professional observatories use. Sadly, we don't have that.
Yes.
Alan
Bit
Stern.
expensive.
Yes, it's Alan Stern.
Alan Stern. Okay.
Yeah.
Yeah. So you can notice the outer ring of Saturn is a different color and a different density than the main inner ring. I mean, there are actually a lot of rings, but we're not seeing all of them because we don't have quite the resolution to see all of them.
Yeah. Okay, let me see where the stacking was going. It's not done. Yeah, it takes a long time. That's what happens when you have a lot of frames, thousands of them. But yeah, that's Saturn. Mars is gonna have an opposition in October, but pretty good one.
Yeah, those don't happen every year.
Every 2 years, because it's a little closer to us, so it moves along with us. So ends up being that the best time to see Mars is basically every 2 years when it comes into our evening skies. That's gonna be sometime, I think, at like October 10th or 13th. I'm not sure, but yeah, and it'll be bright red and prominent, just like it was in 2018. Except it's going to be a lot higher now. It's going to be 60 degrees above the horizon. And that's going to be excellent for viewing and imaging. So
yeah, you definitely want to have your telescope by
and
then.
This time hopefully there won't be a dust storm. Last time there was a dust storm, and that kind of made the opposition a little bad.
Yeah, because Mars is the one planet where we can see surface features, but a dust storm can mess that up.
Well, it's not the only planet we can see surface features on. It's the one that's the easiest to see surface features on.
Well, at Mercury we can see maybe?
Some imagers and some very, very experienced visual observers can see detail on Mercury. It just requires really good seeing, really good timing and planning on your part to see Mercury. But for the average observer, with the telescope, you can see the phases of Mercury, but you can't really see the surface detail. That requires some really good conditions to see that.
Okay, we got Bill Cecil is chiming in here that according to Astronomy magazine, 82 moons. Jupiter has 82? No, 79.
That's a lot.
Neptune 14 and Uranus at 27.
Well, they can only go up.
Yeah, they don't go down unless one
the realities of planets keep finding more and more tiny little rocks. Okay. Stacking is taking a little time. Does anyone want to go back to? I guess we can go back to Jupiter now. See how that turned out.
Okay.
We might be able to see a little more different detail now that it's rotated quite a bit. The thing about Saturn, it doesn't really have a lot in surface detail, like the cloud detail, besides this one little band across it, and basically a little bit of banding. But Jupiter is very intricate, so I think we can see that by looking at this. So we'll see how that's rotated. So I'm gonna go back to Jupiter.
And Jupiter has a really active magnetic dynamic.
Yes,
right?
It's got a very huge magnetic field. Partially extends all the way to Earth. The magnetosphere of Jupiter actually extends all the way to Earth.
Wow.
It's okay. Let's see if we're anywhere close. I don't think we are.
Okay, I think we have some new people on board, so I'm just going to mention again that August 15th we'll be doing another star party. This one will be a grand tour of the sky. It won't be focused on the planets so much as on the deep sky objects, galaxies, star clusters, and nebulae. So tune in then, and we'll be starting at 9 o'clock. We'll be starting a little earlier because it gets dark earlier, which we like, although the nights are getting shorter, but still pretty good. So that's August 15th, 9 p.m., same time, same place. And as I said before, send us an email if you want to be on our list, and we'll keep you informed of what we're doing, both for the Julian Dark Sky Network, which is juliandarksky@gmail.com, and curiositypeak@gmail.com. And the difference is Curiosity Peak is a small shared observatory where we do our amateur astronomy, and the Julian Dark Sky Network is a group that fights for the preservation of the natural darkness up here in Julian and everywhere else, but we're especially focused on Julian, and we're working to become an international dark sky community so that people, generations to come, will be able to come up here and enjoy the night sky. And we do this in unity and learning from the International Dark Sky Association. Okay, so let's see, we got...
Okay, I'm back.
Okay.
I got it now. Let's get that focused, though. You can still see the belts. Quite noticeable.
Oh, yeah.
Focus is going to be a little tricky. Yeah, for this kind of imaging, you you focus on the details on the planets themselves, get them the sharpest. Okay, I think that's good. Let me get that a little bigger for people so they can see it better. But naturally, it looks best when it's stacked. So we're going to do that in a sec. Okay. Okay. How did this go? Oh, it's done. Another.
Okay.
Let's go back to the moon for a little quickly.
Okay.
We can put this in the corner. Let's look at a nice little stack of the moon. And the reason why there's a... Let me make that a little bigger. The reason why there was cut edges at the top is because there's a lot of motion, so I kept moving a lot, so I wasn't able to properly sample those parts. But let's process this and see what we got. Yeah. I think Doug can see. Can you see that?
Uh-huh.
You got that process view of the crater now.
Oh, yeah. Uh-huh.
You can see the effects of the atmosphere when I didn't have the corrector set, but yeah, looks much better than before.
That's nice. Uh-huh.
That's before, and that is after. Let's get to something else stacked real quick.
Yeah, we can see details in the crater rim itself. Oh yeah, look at the difference.
Yeah, let's get Saturn stacked so we can look at that. But yeah, that's that crater, and you can see that ejecta, that mountain in the center of the crater, and you can see the rim. This part of the crater is still in shadow, still experiencing sunrise. Yeah, that's the edge of the moon right there.
Well, a lunar day is 28 days, so sunrise is pretty slow.
Yeah, it's not as interesting. It takes quite a while for it to set. Okay.
Yeah, imagine you could sit and watch the sunset for 28 days. Well, no, it wouldn't take 28 days for it to set, but.
Okay, well, while we're waiting for Saturn to stack, it shouldn't take that long. You got that view of Jupiter. It's a little bit out. But let's look at the moons again. Turn up, turn up, turn up. Okay. Now it should be very easy to see them now. There we are. Callisto on the left. Ganymede on the right. Oh, 3 minutes, Europa's coming back. They're on time.
3 minutes? Okay.
Let's just watch that. Let's watch for that to happen. Check on the stack really quick. But yeah, anytime soon we're gonna have reappearance of Europa from Jupiter's shadow. Yeah. What's the live chat saying?
Let's see. I got to get out of the full screen. Okay. Just that someone was asking about Pluto and mentioned that you need a bigger telescope to see it. Yeah, Pluto's way farther out in the solar system, and it's also not as big as Jupiter and Saturn.
Yeah.
So Fred mentioning that the naked eye planets are Jupiter, Saturn, Mars, Venus, and Mercury. So those are all planets you can see without any binoculars or telescope.
Technically, if you're in a very, very dark sky, you can actually see Uranus can be a naked eye object.
Oh, okay.
But you need a very, very dark skies for that.
Maybe darker than Julian?
Yeah. We're talking about like middle of nowhere here.
Uh-huh. Okay, waiting for that moon to appear.
It's in 2 minutes.
Oh, 2 minutes? Okay.
Let's look at that stack. Oh, it's done. I think we can afford a little time. We can just open up that stack of Saturn.
And I would just say that for anyone who's interested in getting more into astronomy, and both practical astronomy and the science, Sky and Telescope magazine and Astronomy magazine both come out monthly and have quite a variety of articles on using telescopes, on research, on space exploration, planetary missions, a whole lot of things. Just Sky and Telescope has been coming out for, I think, 75 or 80 years. I read it when I was in junior high and high school.
Let's get this processed.
They're great resources. Oh yeah, look at Saturn. Okay.
Yeah, there we go. Processed, and we can see the Cassini division very clearly now. Looks much better.
Oh, look at that. Yeah. And the cloud bands. The polar zone has its own coloration.
Yeah, you can see. I
Yeah.
think we can kind of see the hexagon at the very bottom of Saturn.
Yeah, definitely. That's a nice image. So that's the product of many, many, many images, and the best ones being selected and stacked.
30% selected.
Yeah. So that means 70% of the images got thrown out, but the best 30% were used.
Yeah.
And that's the wonder of software.
Okay, I want to make sure I'm the right side of Jupiter here. I don't want to... Yeah, we're on the right side of Jupiter, okay. For the reappearance of Europa anytime soon.
Okay.
I'll let the Saturn image sink though. Let me put that back. More visible. So people can see that. That's their fruits of labor for recording Saturn. Not the atmosphere, like the atmosphere refraction is not completely corrected, but did the best we could. Are we on the right side, actually? I think it should
Well,
be...
it's going to, when it appears, it'll be just on the limb, right? So.
I don't know, yeah. It won't be on the
Oh,
limb.
but it's going to emerge
The
from the
shadow.
Yeah, okay. Right, this depends on which way the shadow
Oh, there it is! I can see it.
Okay.
Let me turn up the gain so people can see that. I just spotted it. There it is. Starting to reappear. It's going to get brighter. Can you see that?
My eyes are not quite as
Let me
young
get
as
that
yours.
for people. Here we are. It's starting to appear. It's getting brighter.
Oh, I think I see it on the left side.
Yeah.
Yeah. Oh, there it is. Yeah.
It's coming up. Yeah.
Okay.
Yeah.
Okay. Europa is back.
And the atmosphere really doesn't like us.
No.
But yeah. You just saw a moon of Jupiter reappear from its shadow. Like, you couldn't see Europa before when it was closer to Jupiter because its shadow was being cast. The shadow of Jupiter was being cast on Europa. Now you can see it more clearly. Let me turn on the gain even more.
Well, that was kind of a lunar eclipse then that happened.
Yeah.
Except it wasn't our moon. It was
What's the live chat say?
Let's see. Saturn is beautiful, and it's great to see it so much more clearly. Very nice. Fabulous. Yes. Back up. Fred said. I'm not sure what that means. Back up.
Let's look at... Let's look at one of the other lunar images, possibly, as we watch this session end. Yeah, our Aristarchus should be nice. One more lunar stack ready to come up. But yeah, I think we can see it's a pretty... We can see Europa clearly now, so let me back up to Jupiter now. There we are. Let me get the focus right.
Oh, by the way, if you want to spread the word about the star parties, that would be really appreciated. And people can watch a recording of each of them on YouTube. So if you go to the same place, our studio, anytime, you just click on any one of them and watch the whole thing, including the chats, I guess.
Let me just go back to what we got so far out of the session. Yeah. It's got... Let me get that. Yeah. Still stacking. But yeah, this is what we got out of just those videos.
Uh-huh.
That's the power of the processing we can do. Yeah, but
So it's a fascinating hobby. You can get into it a little, or you can get into it a lot.
yeah,
Nobody starts out
this the
doing
seeing
this
the
kind of
seeing
imaging.
the seeing right now isn't that, it's not great. Like, it could be much better. And that's when, like, when I took the, like, when we posted that animation on Facebook, the seeing was much better than it is today. But I think we did get some pretty good results with what we had.
Yeah, I would say so. I mean, this was done on the fly.
Yeah, and it's right now, they're not that very high right now either. So yeah, I think we did pretty good.
Yeah, all right.
I'm just gonna let the final stack. If anyone wants to see, go back to something, they can let us know. But I'm just gonna let this one final lunar image stack. But yeah, if anyone has questions, you can also ask those.
And any comments you want to send us by email are fine too, if you want to be a little more private about your communication.
Oh, get the.
Yeah, one thing I'll have to say, we didn't have a cloudy sky tonight. That is good.
It's only 10:46, so you can't say that. You can't be too sure about that.
Yeah. Well, as you can see, Vivek is just starting to reach his stride as far as energy, so we may go on for a while.
Well, I'm just talking about the marine layer.
Yeah, I know.
Usually when it's
Right.
out here, it comes a little bit later.
Yeah.
But it does come, and it's very annoying.
Very annoying for Vivek out there in San Marcos, but for us up here in Julian, it's
Well,
kind of.
I think we got some stuff in the live chat.
Yeah. Okay. Show us Trappist 1G. Okay.
Maybe one night we could have a live stream where we actually live view. We could have an exoplanet transit.
Yeah. Uh-huh.
We could do that.
Exoplanet detection.
Yeah, so we could, like, maybe like during one of the deep sky star parties, we can just have a setup and we can check in the progress of the light curve. Because when you can actually monitor a lot of telescopes, like amateur telescopes, or even a camera lens, you can point it to a star as a transiting exoplanet, one of the more observable ones, and you can actually see the decrease in brightness due to that exoplanet transit. And it's actually amateur observations of looking at those exoplanets is important, because that's how we keep the timing of when those exoplanets transit fresh. Because when large observatories want to look at these exoplanets, they don't have the time to wait for the exoplanet transit. They need to know exactly when it's going to do that. So amateur observations can help keep those times fresh. Another thing they can do is also confirm exoplanets, because we have a lot of targets of interest that aren't confirmed, and amateur observations can actually confirm them. So.
Okay, we have a request for the future of some spectra.
Oh, doing spectra on a live stream?
Yeah, spectroscopy.
Yeah, we can do that. Yeah. A lot of ideas. Yeah, well, yeah, the only difficult part of doing spectra on a live stream is it'll be a little. Actually, yeah, we can. Actually, I think that's very doable. Okay, yeah.
At least we know one person would like that, Fred.
Yeah.
But yeah, but it is a really important tool for investigation. So.
Did someone? Is there any other requests from people in terms of like what we can do now?
Tonight?
Yeah.
Yeah. Is there any objects that anyone would like us to turn to tonight?
Well, in terms of planets.
So, in terms of planets.
Yeah, we can't do deep sky right now.
Yeah,
we're not set up
right.
for that. I mean, actually, how's the stack doing? It's still stacking.
Well, is Neptune within reach?
No,
or Uranus?
That's not up right now.
Yeah.
Yeah, Europa is not going to cast a shadow tonight. It's going away from Jupiter. It's coming from behind Jupiter. That's when the shadow was cast. Yeah, but let's actually.
Okay, what about asteroids? Okay, Fred's asking about Ceres or Vesta.
I don't think those aren't very high right now either. And also this kind of setup isn't very good at that either because those are fainter. Those are like magnitude 8. These are for this kind of setup where we are at very high focal length to get high resolution. That's mostly for the planets. Like actually, you can actually resolve Ceres and Vesta with the large telescope, like 12 to 20 inch, but you just need very, very good seeing to be able to do that.
Yeah, because it's very, very tiny.
Oh, our last lunar stack is done. We can process that. Yeah, we can do it. Yeah. Oh no, that's the same one. Oops. Yeah. We'll definitely think about trying to schedule one on Spectra and I guess one on. What was the other request?
No, but people can feel free to email us. In the meantime, requests, suggestions, ideas.
So it's only Spectra.
Yeah.
Okay. Oh, there we are. Well, it's not the best, but we can see the detail on it.
Oh, yeah. Wow.
Let me get that bigger.
Uh-huh. Oh, that's great detail, yeah.
No, the stack from before was like that.
Mm-hmm.
Yeah, right. This is processing on the fly. It's not tuned. Like normally when you would process this, you kind of tune the settings to get the most detail or get the color balance right. But I just have like the process I'm doing right now is more batch processing just to get that quickly done so people can see the detail. But yeah, I think that's the final stack for tonight.
Okay.
Yeah.
All right. Kathy is saying thanks to all who attended, shared comments, information, and welcome to Margaret, our first-time visitor. And we hope to see you all again. And keep spreading the word. It definitely inspires us to keep on doing it. So thank you all, and keep in touch with us through email. We hope to resume live in-person star parties, but that all depends on the eradication of the virus. So we could talk for hours about that. I'm sure everyone has. Okay, so and Fred's antics wouldn't be complete without them, man. Okay, all right. Well, thank you, everybody. Thank you, Vivek. Vivek did most of the work to put this together. He's, got his equipment set up in his backyard, and this is, I'm just kind of the sidekick right now. So we'll be together at the next one up here in Julian, and we invite you all to come back. That's August 15th, 9 p.m. for a tour of the night sky, grand tour. Okay? All right. Good night, everybody.
Good night.